Okay, 8.4a. Remember in semester 1 when we talked about proofs and logic? Remember when we write the converse of certain statements? The if statement, if and then statement. Our if statement is our hypothesis, and our then statement is our conclusion. So this is just a quick reminder. So the converse, our hypothesis and our conclusion is switched. So we keep the if and we keep the then in the same places, and we just switch the other parts. So now, if it is cold, then it snows. So that is the converse of anything. And just a quick reminder, when we solve proportionality, we cross multiply. So here we cross multiply, so this becomes 8 times x plus 1 equals 4 times 7.5. Change that. Then this distributes to make 8x plus 8 equals 30. Subtract 8 to both sides. 8x must equal 22. Divide by 8. Our x here equals 22 over 8. Today we're going to talk about the triangle proportionality theorem. And that basically says if a line is parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. And we have seen this triangle in our assignments, and we have every single time seen it proven this triangle to be similar, the small one similar to the bottom one. So don't forget the top to do the top over the bottoms. So if you look in our triangle, that means now we can say 4 is proportional to 8 is equal proportional to 8 over 12. So this part is proportional to the whole part, as this part is proportional to this whole part. And we can always cross multiply to find out what x is. So we have 8x must equal 48. Divide by 8. X should equal 6. So let's try some of this out on some of our examples here. So we can use small, the tops over the bottoms, so the small parts over the bottom part. So we can say x over 21 should equal 4 over 14. We'll cross multiply. This gives us 14x should equal 84. Divide both sides by 14. X is 6. Let's set this up again. Try this again. We have this now. We have this whole thing is 20. Well, this little part is not 20, but that part is y. So this little part is actually 20 minus y. So now when we set it up, we can say that y over 20 minus y should equal 3 over 9. We can still solve this. We just got to cross multiply, use our steps. The first is 9y. 3 times 20 minus y gives us 9y equals 60 minus 3y. I'm going to move this over here. First, I'm going to add 3y to both sides. Continue over here. This gives us 12y should equal 60. divide by 12, divide by 12, y equals 5. All right, let's go on, try this next one. We have x over 4 equals, now it's 10 over 5. X over 4 and 10 over 5. So let's cross multiply. This gives us 5x equals 40, divide by 5, divide by 5, x equals 8. Let's keep going. Remember, we got 14 here, so this makes this over here 14 minus y. We have y over 14 minus y equals 15 over 6. Cross multiply, we have 6y equals 15 times 14 minus y. 6y equals 210 minus 15y. We can add 15y to both sides. I want all the y's on the same side. This gives me 21y equals 210. Well, that's pretty simple. We can divide by 21. Y should equal 10. All right, next one. Our converse of our triangle proportionality theorem. So our triangle theorem says that if a line divides two sides of a triangle proportionally, oh, started to spell that wrong. Then it is parallel. So before we were using the parallel to prove these things, and now we can prove that the lines are parallel. So it's basically saying if we find the sides proportional, then this has to be parallel. These two lines right there has to be parallel to each other. So let's set it up. We got to check to see if it's proportional, and if it is, we'll find out if it's proportional. Remember, we want the tops over the bottoms. So first, we'll use 48 over 16. Let's check the proportions on that. Divide both by 8. This gives me 48 divided by 8 is 6 over 2. I can simplify that some more. So 48 divided by 8 is 6. 16 divided by 8 is 2. Divide that further by 2. This gives me 3 over 1. Okay, so that's one side. Let's check the 56 over 21. I wonder if 21 goes into 56. Nope. Let's see. Let's try 3 or 56 divided by 7. Let's do 7. Divide by 7. This is 8 over 3. Okay, we can't reduce 8 over 3 anymore. 8 over 3 does not equal 3 over 1. They do not equal each other. So basically, 8 over 3 is not equal to 3 over 1. So these lines are not parallel. So not parallel. But let's try some of these other ones to see if they are parallel or not. So first one, tops over bottoms. 4 over 8. Simplify that. Divide by 4. Divide by 4. This gives me 1 over 2. 6 over 12. Divide by 6. Gives me 1 over 2. So yes. So here we can say that QR is parallel to ST, these two lines right here. Let's try the next one, tops over bottoms. So 15 over 21, We'll divide those by 3. This gives me 5 over 7. The other one, we got 17 over 23. We cannot simplify. Both are prime numbers. 17 over 23 does not simplify anymore. And these are not equal. So no, this is not parallel at all. Next one, tops over bottom. So we'll say 10 over 4. We'll simplify that, divide by 2. This gives me 5 over 2. And then 20 over 8, divide by, what, say 4. This gives me 5 over 2. So yes, this is, and so we can definitely say KL is parallel to MN. Last example here, tops over bottom, 72 over 40. Let's divide both by 8. This gives me 9 over 5, okay? 90 over 50. We can divide that by 10 easily. And that also gives me a 9 over 5. So yes, this is, it works. So we can definitely say PS, these two lines right here, PS is parallel to QR.